Hello and welcome. As you can see, we are going to discuss today the vector and scalar quantities, and we will also be discussing in this either in this video or in another videos these concepts which are mentioned on the screen. The first we are going to discuss vector and scalar quantities. Then we will discuss about equality of two vectors. That is what does it mean by being equal vectors. And then we will discuss vector addition. And then we are going to define the vector quantities. In fact, not earlier than this. Then we will define multiplication of a vector by a scalar. Subtraction is not defined for vectors. Vectors undergo through addition or multiplication only. Their division and their subtraction doesn't mean anything. Rather, division by a vector is a dumb idea, meaningless. So, because why we will see pretty soon. And then we will discuss the resolution of vectors. Then we will go through the unit vectors. Then we will define the multiplication of two vectors. They are multiplied by two, multiplied in two ways. One is called the dot product. That gives you, when you multiply two vectors, you will get a scalar. And then we will multiply two vectors and get a vector, and that is called a cross product. And then we will have another thing that is important to us, that is called a scalar triple product. It will come in later chapters, so I'm going to describe all in this chapter, all of these concepts in this chapter. Let me first describe you the vector and a scalar quantities. And though perhaps I will not be able to provide you a definition right now, but I will try to explain things. Suppose you want to specify fully the motion of a car, then we must answer the following questions. The first question will be, it will naturally come into your mind, how fast? This is the first problem. And the second question will be that will come into your mind will be naturally which way. The first question, how fast, is answered by the speedometer reading. If you can read the speedometer of your car, you will know how fast your car is moving at the moment, which is simply the speed of a car in kilometer per hour in India. The second question, which way, is somewhat tricky. You can specify it by using several tools. For example, you can use a coordinate system. That's true, that's right. We will also use, not right now. Or you can use the map tools, like you will specify first that on a piece of paper the directions north, south, east, west. And if your car is moving in this way, you will find the angle. Suppose this angle came out as 30 degree, then you are going to tell this direction as your car is moving in a direction 30 degree north of east, 30 degree north of east, and like this. Graphically, we may use a directed line segment or an arrow. This is the king here. Directed line segment or an arrow. Geometrically, graphically, we use a directed line segment or an arrow to describe the velocity of a car. The directed line segment itself is called the velocity, whereas the length of the directed line segment, that is the magnitude, is called the speed. You know it. There are many physical quantities that are represented by a directed line segment and can be described by specifying a magnitude and a direction. The most common example is the force. Yeah, this is the most common example where the magnitude of the directed line segment is a measure of the intensity of the force. How big is it? And the direction is evident from how the force is applied. Another example is the displacement vector between 2 points on the path of a particle. Suppose your particle is moving on an arbitrary path like this, and there is a point A and there is a point B on the path. If you join these 2 points by a line, this is nothing but the distance moved along a straight line between these 2 points A and B. And if A is the origin from which you started watching your object, and B was its destination till you watch this object, just try to provide an arrow here, A to B, and then write this arrow in this manner, AB, and put an arrow over the head of A and B. So it unites point A and B, and it will describe this arrow from origin to destination, that is from A to B. And this thing is called displacement vector, of course between 2 points on the path of a particle. And the magnitude of displacement vector corresponds to the distance moved along a straight line between the 2 points under consideration. In our case, it is point A and point B. And the direction is naturally from origin to the destination. And we write this arrow as AB, or you can make another anything if you want to symbolize it by a particular letter. You can write like this. And this AB, the length of the AB is, of course, the length of this AB, arrow AB is simply AB. We sometimes write it like this. This is nothing but, you can read it, length of the arrow AB. And we call it magnitude of vector AB. If AB is a vector, displacement is a vector. And this is simply AB, length AB. Though I would suggest you, when you write the AB vector in this manner as vector S, then you should write the magnitude of vector S not simply by S, but the length of vector S in this manner. Just a suggestion. You will understand the nature of this suggestion pretty soon. And then I would like to bring your attention on a simple fact. Suppose that we have two forces acting on a particle. The particle is here, and it is acted upon by two forces. Suppose that one force is in this direction. This is called force F1. Force is also a vector quantity. It's also a directed line. It can be represented by a directed line segment. And there is another force F2 in this manner. Then I'm going to ask you, can you find the combined effect of two forces acting on this particle? Combined effect of two forces. That means the effect of these two forces, in which direction you are going to replace these two forces by a single force. That will be, of course, that force will be the sum of these two forces, F1 and F2 as well. Then it has been known by experiment that The equivalent of these two forces, the resultant of these two forces, F1 and F2 acting on a particle, is equal to diagonal of a parallelogram formed by the graphical representation of forces. How do we make a parallelogram? Well, this is an arrow. Try to make an arrow parallel to it, and then try to make an arrow parallel to F2, and you have completed a parallelogram. And just join the particle on which the forces F1 and F2 are acting, and find and trace the diagonal. And this diagonal will be F1 plus F2, the equivalent, the resultant of these two forces, F1 and F2. This is experimentally verified. You don't need to do anything in this. What I'm trying to telling you that the combined effect of two forces on a particle corresponds to a single force that may be shown by the diagonal of a parallelogram formed by graphical representation of the forces, that is taking forces F1 and F2 as the basis of the parallelogram, and that is the quantity added according to the parallelogram law. We call this these two directed line segments represented by forces add according to a parallelogram law, and all quantities that have magnitude and direction and that add according to the parallelogram law are called vector quantities. We have a definition now that you can say to anybody. If somebody asks you what is called a vector, you can go and tell them that all quantities that have magnitude and direction and that add, never forget it, according to the parallelogram law. According to the parallelogram law are called vectors, are called vector quantities. Yeah, that's right. Other quantities that have only magnitude, such as temperature and work, are called scalar quantities. And you may ask one question that don't all quantities having magnitude and direction combine according to the parallelogram law and therefore become vectors, vector quantities? Did you hear the question? The answer is no. Not all of them do. You may find physical quantities having magnitude and direction, but they fail to failed to be added. They fails to be added according to the parallelogram law. And what kind of physical quantities are them? I am under impression that all the physical quantities we are going to study in our studies, in our study plan, will be either vector or a scalar. And what about if someone doesn't fit strictly under one of these categories, still we are going to consider them either vectors or scalars, because simply because we don't have the mathematical foundation right now, so that we can distinguish them from each other. So our physical quantities are either vectors or scalar, and to be vectors, they must have some magnitude and the direction, and the most important thing is they must add according to the parallelogram law to be considered as vector. Otherwise, they are a scalar. And how do we add the scalars? Like numbers. So we don't have a problem. All physical quantities that fail to be a vector will be a scalar, and their treatment will be like numbers. So we don't have to worry about. There are many having magnitude and direction. One is finite rotation. I will not explain this right now because it will take lots of effort and time. But finite rotation, they also have magnitude and a sense of direction, but they cannot be added like 30 degree plus 60 degrees is 90 degree. They can't be added like using parallelogram laws. And another famous physical quantities is electric current. And you will say they also added like numbers. They don't follow the parallelogram law. So, despite having a direction, they can't be added using the parallelogram law. So, they fail to be a vector, and so they are scalars, nothing else. Now, I have not reached yet addition of two vectors. I am not talking that I have finished the addition of two vectors. Before that, I need to do some work as well. But before that, I am going to explain equality of two vectors. What does it mean by being equal vectors? So, there is a definition. Someone told me that two vectors are equal if they have the same dimensions. Perhaps you may have an idea of dimensions. If you don't have, try to find the idea of dimensions, because I'm not going to describe it right now. So two vectors are equal if they have the dimensions, magnitude and direction. Suppose two vectors are having same magnitude and same direction, but one is displacement and another one is velocity. How can they be equal vectors? They cannot be. So they must have the same dimensions as well. And so for equality, we have to consider three factors again: same dimensions, magnitude, and the direction. This one. Now we are going to talk about addition of two vectors. So the first thing you will need to know that how to find the angle between two vectors. In case of displacement, it is quite easy, but in case of forces acting on a single point, how are we going to find out the angle between two vectors? If we have a common tail for two vectors, move from one vector to another, move from head of one vector to another through the a smaller angle, and this is going to be the angle between two vectors. Just verify that you are moving from one vector to another through the smallest path by the smallest rotation, and you will get your angle. And in case if you have two vectors joined by their heads, you can do the same thing. Start from one of the vectors and move through the other through the smaller angle, and you will get the angle between two vectors. So it's easy. But what if you make two displacements? First you move in this direction and then moved in this direction. What will be the angle between these two vectors? These are two displacements. Suppose that this displacement is S1 and this displacement is S2. What will be the angle between them? You will be tempted to choose this will be the direction between these two vectors, but this is incorrect. This cannot be. Why? Because these arrows are thought to be a close relative of light arrows. If you remember your ray optics lessons, you will know that now you have to consider these arrows as light rays, and you are going to find it pretty soon that this arrow was initially traveling in this direction. So you can easily consider that this light ray was moving in this direction initially, and it changes direction in this manner and converted into this ray. So this should be thought like deviation of a light ray, and deviation of a light ray always takes place because light has a tendency to cover the shortest, to move through shortest distances or cover in shortest time. So these are called principle of least action. So this arrow is going to deviate in this direction. It doesn't have a choice to deviate like this. This is meaningless. So the question of this angle is not even under the consideration. The choice of this angle at your screen is not even under the consideration, so you don't have to consider it. You can consider it something like this, but this is not the nature of light, so you're going to consider it. So this is the only choice. And whenever you got two arrows like this, you have to bring a light bulb in your head, and you have to just produce one of the preferably the previous arrow, and then you have to simply deviate towards the next arrow through a smaller angle, and this will be the angle between two vectors. So these are the things here. Now you can understand the angle between two vectors. You can get you are ready to read the idea of addition of two vectors both the laws, parallelogram law and triangle law, and you will eventually find that both are the same laws. So I'm going to cover this thing in other lecture. I just want to make it simple and short, nothing else.